Hello, Math 1050. This is section 2.6. We're going to be working on transformations of graphs. There are 8 topics in this section. In this section, we're going to be looking at a lot of different types of functions. So this kind of is a summary of the ones you should be familiar with. You should be very familiar with quadratic functions, and we can use our pattern of up 1 over 1, up 3 over 1, up, 5 over 1 to help us graph those. Cubic functions, the one right next to it, I'm probably less familiar with this one or with a pattern for this one. So as we graph those, we're going to use a table. You're probably very familiar with absolute value functions, so we're going to be doing some stretches with absolute value functions, and just remember we're counting the slope on these when they're stretched. And then square root and cube root graphs at the top here. Remember, a square root is the inverse of a quadratic, so it does a 1, 3, 5 pattern sideways. And for a cube root function, it is a 1, 7 pattern or use a table. This last one, reciprocal, it will come up in a future unit, so you don't need to worry about that one right now. When we start transforming functions, there's several different types of transformations that can happen. The first two are translations, if we actually move the function to the left or to the right or up or down. So if you have a number or a constant that's being added to the function or subtracted from the function, that's going to shift it in the up or down direction. So a little example over here, you would see the +3 outside of the root. That would mean that I take that square root graph and shift it up 3 units. Or if it was this -1, down 3 units. Horizontal translations, you'll see the constant being added to the x in the function. So if you look over here to compare, my -5 and my plus side are inside of the root with the x. That tells me that it's in the x direction. Remember that these ones kind of are counterintuitive. If you see an x -5, that is going to go to the right 5 units. And if you see an x +5, that's going to go to the left 5 units. We can have vertical and horizontal stretches and shrinks as well. If you see a function multiplied by a value, that's going to be a vertical stretch. So if it's in front of that root there, that's stretching it really tall for the square root function. If it's inside the root or whichever function type you have, like with the x, that's going to be a horizontal stretch or shrink. Those are probably the ones that you are the least familiar with. The vertical ones make sense, and they are, stretching it vertically by that factor of a. Horizontal ones, always counterintuitive. It's stretching it by a factor of 1 over a. Like, we need to think of dividing by that a instead of timesing by that a for horizontal. And I will show you some examples of that. Reflection really kind of is the same idea as a vertical or horizontal stretch. It's just that if it's a negative, the net effect of that is going to be that it literally flips the thing over. So a negative root of x, instead of going up and over, it's going to reflect and go down and over. So if the negative is in front of the function type, that would be a vertical reflection. If the negative is with the x, then that is going to be a horizontal one. So the square root of negative x, instead of flipping, so our function normally would look like this for a square root. This function would be going back this way. So it'd reflect it over the y-axis. So that's probably one that you're not as familiar with, and I'll show you where it comes up in your topics. Okay, so the first topic is just to graph a stretched absolute value function. So the basic absolute value function is just that V shape with a slope of 1. The stretch right here of 4 means that the slope or the stretch amount it's going to go up 4/1 to the right and then also to the left. In ALEKS, you'll have like a ray tool that you'll use. So you can kind of think about where the vertex is at the origin and then just stretch it up 4, and you can count off that slope if you want, 1, 2, 3, 4/1, and then just do another ray on the other side to create that absolute value shape. The next function is to graph a parabola. These ones are going to have a vertical translation. So for example, the one that I'm going to graph right here is shifted up 5 units. But in this topic, you won't see any left-right translations, just vertical. And then we also have a stretch right here. For these parabolas, you have to plot 5 points to graph it. So the vertex of this is at 0, 5. And this is reflected because it's negative. -2 is the vertical stretch. So if you like to use the patterns, normally it would go up 1/1, up 3/1, up 5/1. So the stretch of -2, it's going to take each of those vertical pattern, the vertical part of the pattern, and multiply it by a -2. So this thing's going to go down 2/1. That's from this. Then it's going to go down 6/1 from this sort of step in the pattern. And then it would go down 10. Now that's not even going to fit on our grid. And we don't need to plot that point anyway because we just need to plot a total of 5 points. And we already have 1 right here. So down 2/1, down 6/1, and then I'll do the other side. That gives me my 5 points. And then you can click on the graph button. Wow, really good graph, Bricky. And then it will plot it. In this topic, some of them have a fraction. So if you have one like this, what I would recommend, the stretching pattern is really hard to use with fractions. So if this is the case, I would go ahead and just use a table. Sub in 0, 1/2 times 0 squared plus 3 is 3. Sub in 1, I get 1/2 times 1 plus 3. So that would be 3.5 or 7/2. And then sub in 2, and I get 1/2 times 2 squared is 4 plus 3. So that would be 5. And then use that point tool to graph the fraction ones. And 1, 2, 3, and that will help you get your stretch correct with the, whoops, I totally plotted that in the wrong spot, with the fraction. It's really tricky to get the fraction stretch right. And then a 5. So this is going to be kind of like a wider, and then you can of course reflect it to get the other half. This is going to be like a wider parabola. Okay. The next topic is graphing a cubic function. For this one, I would absolutely recommend that you use a table of values. These almost all have a fraction stretch. So you can just use -2, -1, 0, 1, and 2 for these. They are kind of centered at the origin. And just sub in 7/8 times -2 to the third. That's -7. 7/8 times -1 to the third. That's -7/8. So you'll have to use the little tool to plot that one. Subbing in 0 is super easy because it is just 0. And then these ones are going to be the same kind of as the ones we did at the beginning. They are just going to have a positive sign. Anyway, so I would just sub in all of those values, and then you can plot those to get the shape of the graph. Once you plot those 5 points, you will be golden. You'll have it. Whoops, that's not very good. There we go. Okay, the next one is the square root function. So just as a reminder, square root is sort of half of a parabola. So the pattern we usually use is up 1 over 1, up 1 over 3, up 1 over 5. So it is a 1, 3, 5 pattern, but it's sideways. When these things are stretched, the up is what gets stretched. So in this case, our pattern is getting stretched by a factor of 3. So I'm going to go up 3 over 1, up 3 over 3, up 3 over 5. The starting point with the x, so in the horizontal direction, it's moving forward 1, not moving up or down, because we have a, no constant at the end there. So in ALEKS, it will tell you to plot the leftmost point, and that's the like what would be the vertex in a parabola, but for this one it's just the leftmost point. So if you like to do this with a pattern, plot that starting point and then use your pattern up 3, 1, 2, 3 over 1, up 3, 1, 2, 3 over 3, up 3 over 5. The 1, 3, 5 sideways pattern will stay the same. It just, if it is stretched, it's stretched vertically. So you can see I went up 3 each time instead of going just up the regular 1. For the next 2 topics, you'll just have to drag the shape to its new location. So it'll have a graph like this one on your screen, and it will say translate it to make it the graph of a new function. So you just have to think about where you want to move that v. So for this one, it looks like we need to move it to the left 5 and up 2 units. So left 5 up 2 would put my vertex here. And then you just drag it over and it'll be in that location. We also have a version of that with a parabola. It may even be a reflected parabola like this. So we've got the graph of negative x squared. We need to turn it into this equation or this function. So we need to move it forward 2 units and up 4 units. So it would be here, and then, it'll already be that right shape. You'll just drag it to that starting point. Okay, the last topic is the trickiest one. What the topic requires you to do is take a shape like this one and transform it. So for example, this one, it wants me to do 2 times h of x minus 3. So I just want to talk about those different translations and kind of the order of operations here. When you're doing these transformations, you need to do your left, right shifts first. So it's kind of like we start as close to the x as we can in the function. So a left, right one is going to be done first. Then we're going to do the stretches. And it doesn't really matter if you do, doesn't really matter if you do the vertical or horizontal stretches first. You're just going to do all of those stretches. And that's because the stretches are sort of next. Horizontal one here and vertical one here. Stretches and reflections, I guess, are really kind of the same. It just, a reflection is just a negative stretch. So you would also do reflections. And then very, 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 very last is to shift it up or down. Always last. A vertical translation is always graph to last for this type of problem. Okay, so you'll have a shape. I'm just going to pick like a couple of these to do. I'm going to do this one and this one and this one. Okay, so I have this shape that I'm given, and I'm going to start over here. I need to graph negative f of x plus 2. Well, always start with your horizontal motions. So I need to go back 2 units. So if I shifted this thing back 2 units, just think about each point moving. So this point would now be here. This point down at the bottom, if I move it back 2 units, is going to be at -1, -1. And then if I move those 2 points back, they're going to be here. So this is, I guess, just that motion of moving them back 2 units. But then before I finish my problem and submit it, I also need to do a reflection. So I need to reflect it over the x-axis. So this point was way up high. It's now going to reflect down low. This one was a little bit low at -1 height, so it's going to go up to a +1 height. And then these two are at a +3 height, so they're going to reflect down to a -3 height. So this would be my final answer. And sometimes it's easier if you do, the first shape and then change that shape. Sometimes it'll be a change that you can kind of keep track of in your head. And then if you're doing this in ALEKS, make sure you erase anything extra that you have on the screen so that you only have that shape on your coordinate plane. So that moved it back 2 units and reflected it. Okay, this next one I want to do is one of the harder ones because it has a horizontal stretch or shrink. So always start as close to the x, in your little instructions as you can. So remember that horizontal changes are counterintuitive. So we are not going to times our x coordinates by 2. We're going to divide the x values by 2. Divide x by 2. So if I think about this x value right here, it's at an x value of -3. So that's going to go to -1.5 because I'm dividing it by 2. Having a 2 with the x there is going to make this thing skinnier. So this one over here is at an x value of 2. So if I divide that by 2, it's now going to be at an x value of 1. And then this one over here is at an x value of 4. So if I divide by 2, it's going to be at an x value of 2. And then this last point down at the bottom is at an x value of 1. So if I divide by 2, it's at an x value of 1/2. So I just did only, so it's skinnier now, I only did this change. So now I also have a vertical translation down 1 unit. But now that I've stretched it, it's pretty easy to shift it down 1 unit. I would draw in my new shape, and then I could delete the old shape that I don't need anymore, the blue one. And then just, of course, make sure that any intermediate stuff you delete, every single extra point you had. I would need to also delete that blue one. I'm not sure I can on the Smart. Okay, let's do this last one right here. As well, again, always start with your x or as close to your x as you have in your problem. This is a horizontal reflection. So it's going to reflect it across the y-axis. So this point, starting at this upper left point, that's going to reflect over to the right side of the x-axis. These two are going to reflect to the left side of the x-axis, and then this guy down here at 1, -1 is going to be at -1, -1. So our shape reflected horizontally looks like this, and then we have a second instruction to shift it up 2 units. So if we shift all of those up 2 units, we get our final answer, which is this one. And then, of course, you need to delete any intermediate stuff that you, that you had drawn to help you along the way. In ALEKS, two shapes that you're specifically going to have to transform are this inverted V, or yours might be flipped over to start with, and then like a slanty one. And this one typically is harder. So let's do this one. 2 times h of x minus 3. This one would shift forward 3 units. So that's not too difficult. And then we also need to do a vertical stretch of 2. So this is going to multiply the y values by 2. So if I think about the y value here, that's a y value of 0. So if I multiply by 2, it's still 0. This one is also a y value of 0. So if I multiply by 2, it's still a value of 0. This point up here is a y value of 4. So if I multiply it by 2, that becomes a height of 8. So this would be my final answer. And then, of course, delete anything extra. So that shifted to the right 3, and it stretched it up by 2. Okay, for this one, we are going to reflect it in the x direction, and then we're going to shift it down 1. So this is an x reflection. Reflect across the y-axis. So this one is way over here. On the right, it's going to shift back to here. And this one is at -2. It's going to reflect over to +2. And this one at the origin, if we reflected that one, it would end up just where it's at. So right now my shape is this one. I'm going to delete these. And then I also need to shift it down 1 unit. So shifting it down 1 puts it here, here, and here. And so that would be my final answer. It's sometimes hard to get straight lines on my tablet, sorry. Oh, whoops, I just deleted the wrong thing. Anyway, delete everything extra from, yeah, so that would be our answer. This one's a little challenging. Let me know if you need help or get stuck on it. Thanks a lot.